Welcome to Math with Professor V. Here's your latest integral of the day. We have an indefinite integral of 1 over x to the fourth plus x dx. And your hint is it just takes finding the partial fraction decomposition and then you integrate right after that. So first things first, to find the partial fraction decomposition, we need to factor that denominator completely. So 1 over x to the fourth plus x. I can take an x out, and then I have x cubed plus 1 left. But ooh, x cubed plus 1, that's a sum of cubes. That factors more. So all the way factored, you should have 1 over x. And then x cubed plus 1 factors into x plus 1. X squared minus x plus 1. Ooh, if you forgot how to factor a sum of cubes, I got you. I have a video on factoring sums and differences of cubes. So I'll link it in the description. Now from here, we're going to have 3 terms in our decomposition. Constant a over x, constant b over x plus 1, and then x squared minus x plus 1, that's an irreducible quadratic. So I'm going to need cx plus d over, that's right, x squared minus x plus 1. How are we doing? All right, very good. Next step, we're going to multiply both sides by the LCD so we can try to solve for A, B, C, and D. So everybody gets multiplied by x, x plus 1, x squared minus x plus 1. So now on the left-hand side, we have 1 equals A times x plus 1 times x squared minus x plus 1. Plus b times x squared minus x plus 1 plus, and then cx plus d times x and x plus 1. Okay, I'm going to use a mix of techniques to solve for a, b, and c. So first I'm going to let x equals 0 so I can get a solved for. So on the left-hand side, I'm going to have 1 equals a times 0 plus 1, that's 1. 0 minus 0 plus 1, that's 1. Plus, this is now b times 0 plus c times 0. So that tells me, okay, great, a is 1. And then I'm going to repeat the same thing. Let's let x equal negative 1. I'm choosing that because then the factor x plus 1 will be 0. So that'll help me find b. So let's see, I'll have 1 equals a times 0 plus b times negative 1. Negative 1 squared minus negative 1 plus 1. That's 3. And then that's 0. So negative 3b is 1. So b is negative 1/3. And then the fun has to come to an end. There's nothing else that I can let x equal to get the rest of the constants. And I don't want to pick some other number like 2 because I have 2 unknowns right now. I have to find c and d. If I only had 1 unknown constant, then I can say, oh, let x be 2 or positive 1, and then I can plug in everything that I already found along with that x value, but 2 unknowns, that's 1 too many for us. So then now I will multiply everything out and then set up some systems of equations to see if I can find c and d. Now, be kind to yourself. X plus 1 times x squared minus x plus 1, that's x cubed plus 1, right? So I just have to multiply a by x cubed plus 1, and then this is also x squared plus x. So just to make the multiplying easier. So now I'm going to have 1 equals a times x cubed plus 1 is ax cubed plus a plus, and then this will distribute now, bx cubed minus bx squared plus b plus, and then I'm going to take cx plus d and FOIL it, right, with x squared plus x. So then that'll give me cx cubed plus cx squared plus dx squared plus dx. How are we doing? Okay, so let's see. Let me set the coefficients equal for, let's start with x cubed. So there's 0x cubed on the left, and then I have ax cubed plus bx cubed plus cx cubed. Oh, this is perfect because I know what a and b are, so I can find c. So I have 0 equals 1 minus 1/3 plus c. So then that means c is negative 2/3. Yay. That was pretty painless. I'm glad I already had a and b. This makes this process easier. And then let's just see, let's set all the coefficients for the x squared terms equal to each other. So 0x squared on the left, negative b plus c plus d, x squared on the right. Negative b would be negative 1/3, so positive 1/3 minus 2/3 plus d is 0. So this is negative 1/3 plus d, so d is positive 1/3, and we are done. That was not too bad. Okay, so now we can put it all together. So we have the following. Originally we had integral 1 over x to the 4th plus x dx. And now I can rewrite that as integral. A was 1, so 1 over x. B was minus 1/3 over x plus 1. Plus c was negative 2/3 x plus d is 1/3. And that's over x squared minus x plus 1 dx. Now, to proceed from here, I'm going to split this up into 3 little baby integrals, so we'll knock them out one at a time. So I'll write this as integral 1 over x dx minus 1/3 integral 1 over x plus 1 dx. They each get a dx when you split them up like this. And then for the next one, be careful. I'm actually going to take out the minus 1/3 from both terms here in the numerator. So I can write it as minus 1/3. Ooh, come on, integral sign. And then this is going to be 2x minus 1 over x squared minus x plus 1 dx. Make sure you're okay with this factoring. I took out a negative 1/3, so then that changed the sign here, and then this is just 2x minus 1 in the top. Okay, perfect. I love it. So here's 1, here's 2, here's 3. I really split it up for the third one because the first 2 we can do pretty effortlessly, I hope, right? So integral number 1, 1 over x dx, that's ln, absolute value of x, plus, I'm going to say c1. I want to save plus c for the grand finale. Integral number 2. You know, I'm going to keep the minus and everything with it just so we don't forget when we put it all together. I think it's less thinking. So just keep that negative 1/3 ln absolute value x plus 1, and then we're going to call this plus c2. Very good. Now the third one. So sometimes these take a lot more work than what this one's going to take, okay? And I've done several in the past. Most of the time, when you have an irreducible quadratic in the denominator, you have to complete the square and then split up the terms in the numerator. One of them will require a u sub and one will require a trig sub. I've done many like that on this playlist, on this channel. This one we're super lucky with. So I thought this was exciting to show you guys. We can just do a cute and clean little u sub. So if I let the whole denominator be u, watch this, let u equal x squared minus x plus 1. What's du? That's right, it's 2x minus 1 dx. That's exactly what we have in the numerator. So when we're not so lucky, we have other techniques, and like I summarized briefly, you would just complete the square in the denominator, so that way you have x minus something squared plus a constant, and then you can do trig sub and u sub, but you would have to split the 2 terms in the top over the denominator separately. Okay, yeah, much more involved. So aren't we so grateful? This is going to be nice and smooth. Negative 1/3 du over u. Yes. Oh me, oh my. Okay, so then this is just going to be negative 1/3 natural log absolute value of u plus c3. And then u is x squared minus x plus 1, which is an irreducible quadratic. Remember, that came from factoring x cubed plus 1. And actually, it's never negative. So when I replace u with x squared minus x plus 1, I'm just going to switch to parentheses. We don't need to keep absolute value. X squared minus x plus 1 plus c3. Okay, so all together, what do we have? A beautiful solution. Natural log absolute value of x minus 1/3 natural log absolute value x plus 1 minus 1/3 natural log, and then this is just x squared minus x plus 1 plus c, and then tell the people, who is this c? C is c1 plus c2 plus c3. And voila, there's our solution. Now, if you're so inclined, you can combine your logarithms. These first two, just move this exponent. Keep the absolute value though, okay? It's totally fine if you leave it like this though. The back of the book had it this way. Personal preference. So anyways, I hope you guys enjoyed this integral. Tell me if you did it differently. I'm curious, but I think this one's pretty straightforward. I don't know how much freestyling you can do, but I love reading your alternate solutions or just how you walk through the process, what went through your mind. That's how we become better at this. So thank you guys so much for your support. Give the video a thumbs up, subscribe if you aren't already, and if you need to review partial fraction decomposition or other integration techniques, then just hop right over to the playlist, Calculus 2 video lectures, or you can watch more integrals of the day because I've done quite a few. And subscribe, turn on that notifications bell. I've been uploading almost every single day. And you can also follow me on Instagram, TikTok, Twitter, Math with Professor V. Thank you guys so much for your support. I love you all. I'll be back sooner than later. Bye.